And welcome back. Quick tea break. I think everyone's refreshed.
Yes.
Everyone's had a moment to get themselves a cup of coffee. I know we've had a quick come down after that big news of the locally manufactured Bucky, Mazibuko Motors M1B. What great news! But now let's turn the clock forward. And I think a lot of people are asking the same question. And hopefully our next two presenters, Tiaan Oosthuizen and Johannes De Vries, who are Mechatronics engineering lecturer and technician graduate from the School of Electrical Engineering at TUT. And they're going to join us with a panel discussion where the four of us are going to talk about prototype solar electric vehicles in a South African context. Okay. Because I think a lot of people are saying, hey, we live in South Africa. Like, can our cars charge from the sun?
Yes.
And I think these two gentlemen are going to help us answer that question. So I don't know about you, but I'm really excited. Tiaan and Johannes, are you there? Are you with us?
Hi, we're here. So glad to be here today.
Glad to
Hi Rob, yes, we are here.
Thank you very much, gents. So Devon and I are both very excited to chat to you guys today and hear about prototype solar electric vehicles in the South African context. So I think we're gonna step back and let you guys take it away, and then when we're ready to have that discussion, we'll jump in. So over to you guys, please.
Thank you. So let's just wait for that presentation to come on the screen. There we go. Thank you so much. Welcome, delegates, speakers, and hosts. Our presentation is entitled Prototype Solar Electric Vehicles in an African Context. And of course, I'm Tiaan Oosthuizen, and Johannes De Vries is with me today. Okay, so myself, I'm an engineering PhD in energy optimization, and I've done this on solar electric vehicles. I've built or co-managed or researched solar electric vehicle technologies for the past sort of 6 years or so. And I've published numerous journal papers on solar electric e-mobility. I've also supervised various state-of-the-art electric vehicle technology advancements with postgraduate students. Johannes?
Yes, myself, I work for the Graduate School of Electrical Engineering. I was a student here at TUT and I stuck around. So I became a team member in 2012 of the solar car team, and then eventually moved over to 2014, where I became the team manager for the team, and then I stick around 2016 and 2018, and we evolve in the team, we develop new technologies, and we recruit more students. Over to Tiaan.
Okay, so just the next slide, Fritz, we're going to look at what we're going to discuss today. Right, so just a quick run through. So we're going to create some context. We're going to talk about electrical vehicles in Africa in a broad sense, how we stimulate awareness of electrical vehicle technology through academic involvement, the Sasol Solar Challenge and TUT, our project and our background, how to develop your own solar car, especially in a university setting, and the various components thereof. Then we're going to look at technological advancements in this area. Some of them, of course, we can't go over all of them. We can have a bit of a break, and then it's our Q&A.
Okay, so creating context, electrical vehicles in South Africa, can it work? I think there's quite a mindset that needs to change for someone to decide if it can work or not. And I think if it's a matter of, if you do buy a vehicle, what do you buy it for? So vehicles are normally purpose specific, and I think it's the same with electrical vehicles. You've got a lot of skeptic people who say, listen, electrical vehicles, I can't tow my caravan. That's not what electrical vehicle is designed for. So it's more of, what is the purpose for an electric vehicle? If you can then define that purpose, then there's definitely a scope for it in South Africa. Looking at world plug-in vehicle sales, you can see that there's a lot of vehicles being sold internationally. South Africa is lacking behind, but it really, the sales of electric vehicle did pick up. And especially on the Tesla Model 3, you can see the top one. There's quite a lot of sales in 2020. We can move over to the next slide to see what was the electrical vehicle sales in South Africa. That's 2013 to 2018. So there was a spike in sales of electrical vehicles, and it's gradually slowed down. Would be interesting to know what the reason for that is, but at least we can see there's more than 100 vehicles being sold annually in South Africa. Let's move to the next slide. So yeah, the big question we always get is what is the purpose of having an electric vehicle, but you can only drive around town and then you need to go back and charge again. So as we can see on this map, there's quite a charging infrastructure. So, and this is being developed on a monthly basis. I think a company, Gridcars, is involved, and they roll out charging stations all over the country. These ones are charging stations already available. And then we move over to Tiaan.
All right, so we're going to look at how do we stimulate awareness on electric vehicle technology through academic involvement, in other words, in a university setting. Johannes?
So TUT, we looking at our track record, we started in 2012. We didn't do that great in terms of kilometers, but the important part is we participated, and I think that was the aim. So we bite the bullet, we say we're going to build a car, we're going to be in the race. I think we spent more time fixing the car than what the car actually drove on the road. And that's why I say, what was the weight of the vehicle? Now, it all depends on when in the race that you measure that vehicle. So it varies from 200 to 300 kilograms. And the reason being, we had a lot of changes made. So we had initial design, but we also had a backup plan. And I think most of the time we used the backup plan, and eventually we moved over to the final design. Then came Sunchaser 1. That was our first fully in-house designed solar car. Sunchaser 1 did 1,800 kilometers, which we were very proud of, especially since it was our first vehicle that we designed and built from scratch. It has 6 square meters of solar panels. The solar panels on this vehicle was imported from China, where on the previous solar car, we actually manufactured the solar panels ourselves. So we bought the cells, we solder them, we encapsulate them, and we actually join them together onto the solar car. Sunchaser 1 weighed 320 kilograms, then compared to Sunchaser 2, which weighs only 265 kilograms. There was quite an improvement in terms of weight. And also Sunchaser 1 did 1,800 kilometers, where the Sunchaser 2 did 2,200 kilometers. And we ended second of all the local teams. And that was a big boost for our team to say, listen, yeah, we are definitely on the right track. We are able to improve on our initial designs. We start to understand concepts, and we find ways to improve on that. The next slide is then focusing on the 2018 vehicle, Sunchaser 3. So this car did 2,500 kilometers compared to the previous 2,200, but taking in mind this vehicle only had 4 square of silicon solar panels, where the previous one had 6 squares. So with 30% less energy, we still managed to do 300 more kilometers on the same road. And I think that was a big achievement for us. And also the weight reduction. So we moved from 256 kilograms down to 188 kilograms. So on this design, we had a lot of focus on how can we do weight reduction and the physical aerodynamic design of the vehicle. Okay, moving to the next slide. Tiaan?
Right, so let's start thinking about starting your own solar electric vehicle team. How do we do this? Where do you start? Right, so let's dive into it. Okay, so it all starts with the solar car, right? The solar car is your main focus. Then branching out, you're going to look at things like design, the race, funding, and stakeholders. And then a little bit wider, we're going to look at the mechanics, the ergonomics, the electronics, strategy, marketing, navigation, community engagement, logistics, procurement, and research. And then a little bit wider even, we're going to look at so many different systems, solar cells, maximum power point trackers, social media budgeting, Forex, having students on the system, finite element analysis, aerodynamics. It's pretty much endless. So let's go deeper into it and see what we can get together in terms of how to actually start a team. Johannes?
So yes, you need to start somewhere, and probably you need to have a team manager. It's quite an important role. You need someone that can keep the team together and can actually listen to what are the needs and have an open-minded approach on what to implement, what not to do, how to negotiate with various parties. So under the team manager, you have a technical manager. That is definitely a very crucial role since it is a technical project. Then moving to the next slide, it will show us under the technical manager, we have mechanical systems. For mechanical systems, we have steering and suspension, which is quite crucial because that will also determine your turning radius of your vehicle and your travel. your suspension travel, and then you have a lot of different mechanical designs, smaller designs like the hinging of the hood or the hinging of the wing, which many teams neglect up to last minute, and it comes around and it bites them. Then you've got aerodynamic development, and then under your technical manager, you have a lot of electrical subsections. One of them is the drivetrain of the vehicle and the solar panel and the charging. Then you've got your sub-circuits, which does your monitoring and communication and testing and data transfer. Then you're looking at your race strategy. So if you are on the race and suddenly the weather change or your vehicle break down, what are you going to do? What is the decision you do have to make? And that's really like you need to decide within the next 5 minutes, you're going to trailer the car, you're going to stop the race, you're going to continue. What is it going to be? Then part of your whole team is also your logistics manager, and that's not just for the vehicle itself and for the race. That's also your manufacturing of your components, your parallel tasking of your different manufacturing processes. And then you've got your procurement manager as well. You want to order your parts in time, make sure your shipment is sorted, your import permits are sorted. So all of these things adds on to what you need as part of your solar car team. So it's not just about building a solar car. It's a bigger business around just the physical technical work in terms of getting this whole project off the ground. Okay, moving to the next slide. Okay, adding to this is also your marketing and PR manager, your community engagement, and also your sponsor engagement. Next slide. Okay, recruiting a team. So it's quite important to define your crucial roles for a team, and you should have a brief description of the key responsibilities in your team. Of course, if it's a rookie team, a starting team, you won't have that many different roles and positions, because getting the vehicle built, designed, and on the road is your main focus, while maybe PR and marketing is less important, so you might focus more on your technical aspects. Then you need to plot the timeline of the project and the expected deliverables linked to dates. Then you need to promote available team positions on social media if you can't fill them in-house. The next bullet is you need to invite possible candidates to a show and tell event. So you need to actually promote your project to be able for students to apply and to select them for the different positions. And then added bonuses when team positions can be linked to studies and to student bursaries. So if it's part of a student's study, he actually needs to do the project to be able to get his degree. Okay, moving to the next slide. So now we have a team. Where do we start? So we always say collect ideas, learn from the best teams. We nearly made mistakes as a team in the beginning as well. Why don't we do this and why don't we do that? The best is go back to the drawing board, learn from what the other teams have already accomplished. Why are they doing that? How are they doing that? And learn from that. So you have to first decide on your basic structure and basic shape of your vehicle. The next bullet is you have to select your components, and your components are linked to your budget, to your sponsors, your support, and your expertise. And then the next bullet, are you going to do software design of your complete vehicle with your FEM analysis, or are you just going to build on the go? So it all depends on your resources and your availability of skills. Then you have to plan your manufacturing process. You need to look at available facilities, and you need to decide what parts are you going to outsource and what you're going to build in-house. Next. And then you need to test your subsystems the moment they are ready. Don't keep everything for the last minute and try to put it all together, and now you have a problem here and a problem there. The moment you have your subsystems up and running, test them and make sure they're working as expected. And then Tiaan will take it from here.
Great stuff. Thanks, Johannes. So we are going to get into the nitty-gritty stuff of a solar car, of an electric vehicle, the engineering things. You can see there in the background, there's a couple of different components of development of the solar car. Firstly, we're going to look at the mix that you need. So disciplinary and multidisciplinary are the two top tiers, and that's where you essentially have, let's say, electrical engineer, mechanical engineer, and someone from logistics or another department working separately to a goal. Multidisciplinary is, of course, where you're working more closely together. Then cross and interdisciplinary is where you are actually starting to work as a team. But what you need for this project to work is, on the next slide, is actually a transdisciplinary approach, right? So this is where you are really, really integrated, and transdisciplinary forms the most complex form of collaboration. It's really actually project focused and goal driven and concerned with real world problems. And that's really what you need to make this work. Johannes, let me quickly go through the timeline before we get into the break. And after the break, we're going to discuss some of the technicalities of the car. So the timeline typically is brainstorming for the first 3 months, collecting ideas, brainstorming, selecting components, identifying suitable suppliers, costing, and so forth for another month or so. Then the body design itself, verifying the aerodynamics in wind tunnels and through simulation, 3 to 6 months. Mechanical design, suspension and steering, 3 to 9 months. Some of these run in parallel, of course. Mold manufacturing for the body, steel frame cutting, welding, and so forth, another 2 months or so. Electronic development, assembly and testing, 3 to 6 months, also in parallel. Manufacturing of composite structures, all the different composite carbon fiber structures for the car, 1 to 3 months, and assembling of mechanical components to the frame, to the actual frame of the car, another 1 to 3 months. And we're going to go into a bit of a break. This is where we participated in the Sasol Solar Challenge of 2018, TUT's Sunstation 3 car. And after the break, we're going to get into more technical details on the car.
Going to share with us?
Okay, so today is the last day of this SASA Solar Challenge. It's been a great couple of days.
Well, welcome back. I mean,
Wow.
a great video showing us some of the skills and expertise that are here in South Africa.
That's
And I
really
think
amazing.
we were just chatting that a lot of people don't understand that we have these skills. This is not, this is manufacturing. This is using composite materials.
Yeah.
This is really big stuff. So Tiaan and Johannes, talk us through the rest of your presentation. I've got quite a lot of questions. People asking how do we bring this technology into vehicles that they can drive on the road. So I'm sure we're going to get to that, but let's go through the rest of your presentation, then we'll get to some questions and answers.
Great stuff. Thank you. Let's go for it. So the next part we'll be looking at when the slide comes on is actually not this one. It's a little bit back, Fritz. It's number 28. So it's about how to approach and understand your funders and stakeholders, right? So of course, funding needs to come from somewhere. You can't just you can't do this out of pocket. So I want to just sketch a little bit of a picture of how to get this funding together. Now, primarily you have three sources of funding. The first one is government, local, and international industry, right? So those are really your three main sources, and that's the who, right? And then the what and the how is what would they be able to give you? Is it cash? Is it in kind? Or is it another sponsorship type? Okay. And remember, cash is always king, because with cash you can do anything, right? And then the why is, why would they sponsor you? It might be for corporate social investment, CSI on their side. It might be for media exposure. It also might be for some other specific requirements that they might have for you to promote them on social media, or they might have specific milestones. So that is around the funding. There's a slide on it, but it's not too important. It's just to recap, it's government, local, or international industry. Those are your three main areas which you can approach. And I think it's crucial. Something like this doesn't come together just from funding that's given from one authority or from one partner. It's really from a conglomerate of partners. There's always quite a few of them. Okay, so let's quickly skim over the budget. Johannes is just going to show us a very, very brief budget.
So we always getting questions, how much do you need to build a solar car? And it all depends on your component selection. So there are just a few items there on this first page, comparing a low budget versus a higher budget. I'm not going to go into detail, but you can see some of these items are pretty expensive, like motor controller and the solar array. So moving to the next budget slide. Okay, so you need to think on composite, what materials. So are you going to build composite, or are you going to build the steel frame? That will definitely influence your budget. And then mechanical, you can outsource a lot of the work. You can buy off-the-shelf components. You can buy second-hand components, and that will also influence quite a big part of your budget. The third budget slide. So there's a little bit more about vehicle signage, race logistics. It depends on the clothing of the team. So how well do you want to represent the team out there, and how much do you want to spend with your photography and your making of your videos? Okay, so in short, you can see there's a budget difference between 360,000 and 2 million rand between the two. And then Tiaan will take the slides from here.
Great stuff. Thanks, Johannes. So next, we're going to quickly look at how does the academic research and practical implementation, how do you find the balance between these two? Because of course we are a university and we have to do this. So we need to divide the solar car designs of the solar car into design categories, of course. So we have levels of complexity, and then we have possible research areas, mechanical, electrical, whatever. Academic student projects can then be created to satisfy each of these design categories. Okay, so first year students or early year students can manage basic design and implementation, and they can rework these tasks into practicals, and you can use this in some of their subjects at the university. You allow about a year or two for actual good results. Final year students can do advanced projects, and this can become some of their final year subjects at university, and you need about a year for them to deliver some results. And usually about 50% of the team is final year students. Then you have postgraduates, masters and doctorates with specific research areas, and you need about 2 to 4 years to really see results in this area. So going on to the next portion, Johannes is quickly going to show us something on composites.
Okay, so looking at our composite manufacturing is the first molds we sent for manufacturing outside, and then we realized, but there's quite a big learning curve that we could actually implement here for the students. Fritz, I think there's a video that might run and show how the KUKA is cutting some of the polystyrene. So yes, there we go. So we've commissioned this robot arm to cut our own molds, and the students are fully operating this robot arm. We do assist them with creating the toolpath on where and how to make sure that the robot is still operating safe and not crashing into the walls and to the roofs. But it's a very nice practical application where the students can actually use industry equipment to manufacturing in-house molds that we use for our solar car. Moving on to the next slide.
Thanks, Johannes. So let's just quickly look at battery technologies and cell management. Now, in electric vehicles, we typically use lithium variants for energy storage, unlike traditional batteries. Lithium batteries can really be volatile. It means that they're flammable and they can explode, right? So lithium type batteries management is crucial. The management of this battery is crucial. It's crucial for what? For safety, for reliability, for longevity of the battery, and for battery health. Data capturing ability is often used for research purposes, such as my own research that I'm doing. The cells you can see there are commonly used in electric vehicles. That's also used in the sort of, what's the e-cigarettes, and they are the 18650 format. And your typical Tesla contains about 8,000 of them, and your typical solar car contains about 420 of them. If we can just go forward a little bit, there we go. So these cells, these lithium cells, are about 7 times lighter than your typical lead acid battery. So they are top of the range. Okay, and now we're going to look at electric vehicle drive motors and the differences between them. So you typically have on the left, you have a direct drive, and then you have the non-direct drive, such as Teslas and other more commercial models. The direct drives, as well as the others, could be PMSM, permanent magnet synchronous motors, or brushless DC, or even AC and DC motors. And the main difference is that the in-hub drive, as on the left-hand side, so the motor is the wheel, right? They're very high efficiency, they're low mass, but they're also high cost. And on the other hand, the non-direct drive is a lower efficiency, higher mass, of course, because there's a gearbox, there's a bit of a drivetrain, but it's more practical for day-to-day usage in like a Tesla or any of the other electric cars that are out there for the purpose of maintenance, cooling, and so forth. All right, now then in the background you can see our interface, our telemetry interface that we typically use on the race. It's just 2 years ago or 4 years ago already. So solar panels and energy management. Now, typically you have the silicone types on the left, which is used mainly on for the commercial and the you typically put these solar panels on your roof, right? So gallium arsenide panels on the right-hand side is about 10 to 20 times more expensive. This is used for typical space applications for spacecraft. They weigh much less, and of course they're smaller. So both these panels can get used on solar cars or on electric vehicles. Of course, the gallium arsenide is just way more expensive. So typically you see solar cars with silicone type panels on them. Right, then energy management. This can actually be a 5-hour discussion, but this was actually what my PhD was on. But in any case, energy management, I think, is just as crucial as the actual streamlined body, the lightweight, the efficiency of the motors, and so forth. We really need to make energy conscious decisions based on the vehicle dynamics. In other words, the mass, the aerodynamics, the friction, etc. There's so many components. The environment, such as the road conditions, the gradient, the distance, the elements, the wind, the sun, the air density, traffic, speed limits, planned stops, all of this needs to form a mathematical model, and then we can do good energy management. So TUT has proved twice already, one in a very rainy day and one on one full sunshine day during the Sasol Solar Challenge 2018, how crucial it is to do energy management. And on the next slide, we're going to see a short clip. It's only a few seconds long. So this specific day, we had a lot of rain come through, and many of the teams didn't plan for this, so they didn't start their cars on the road. They actually trailered, which had them do less kilometers for that specific day. And we we planned ahead. We looked at weather forecasts for 7 days ahead, updated every half an hour of the day, and we actually maximized our distance that day. We were the only South African team that were actually on the road. All the other South African teams put their cars on trailers, so we're quite chuffed with those results. Similarly, there was a day with beautiful sunshine, and it's deceiving because the teams were just doing more kilometers, not planning well for the massive Soloris Pass and the other hills coming up, and they needed to conserve energy really to get over the hill. So that's where energy management is really, really crucial. Okay, so some of the last sections is just the technological advancements of our own car. And if we look on the next slide, we can see how our cars actually evolved from 2014, 2016, 2018. And what you will see when the slide comes up is there's a three-dimensional isometric sketch. You can see that the car is getting smaller on all dimensions. So it's getting smaller if you look from the top. It's getting smaller if you look from the side. It's getting lower to the ground. It's getting, the angles are tighter. It's more aerodynamic. The profile is more streamlined. It's all to do with the aerodynamics. Improving the aerodynamics of a vehicle and therefore using less energy to go forwards. The mass is also, of course, less when your vehicle is smaller. And of course, our manufacturing ability got better as time went along. Right, and then the next slide, it might be a little bit unclear, but this is just in summary to show the advancements of the cars. And you can see the references on the left-hand side with the aerodynamics improved, how the batteries improved. We're typically using the same battery, but our management has improved, definitely. Our aerodynamics has most certainly improved. You can see a typical Tesla Model S is at 0.24 drag coefficient, and our cars evolved from the first to the fourth car from 0.3 all the way down to 0.1. Our solar panels, of course, also have evolved. We use very, very, very advanced silicone solar panels, and we have a 24%, 24 point something percent efficiency, which is quite good. Our top speed is still around 120. It might be 140, and it's about 250 kilometers that we can do with no sun, and about 500 kilometers that we can do with full sunshine. You can also see the weights at the bottom decreased dramatically. Right, so lastly, that's a rendering of our new car, our current car, which is in development, which should be done in a month or two. And yeah, that's Sunchaser 4. We're really proud of it, a lot of advancements there. And then finally, on the next slide, it's just electric vehicles in Africa, most definitely, bring it on. We're ready for it. And that's it from us. Thank you so much. We'll now gladly accept some questions.
Cool. Look, really exciting, and it's great to see that we've got that kind of technology in South Africa, and to hear that this is what's happening. And I think what we're seeing a lot of questions straight on is, people are asking, transferring this technology to vehicles that they could drive on the road. I mean, the solar cars look great. Obviously, it's a single occupant vehicle. It doesn't look like the vehicle you're going to pop down to the shops and go pick up bread and milk with. So how do we transfer what you guys are doing into a vehicle that, we were talking to Chris Selwood earlier, and he was talking about a vehicle where you can pull off on the side of the road, have a cup of coffee, and it can charge from the sun. How do we transfer what you guys are doing at the tip of the spear, a little bit backwards to vehicles that we could drive on the road?
Okay, let me try and answer that, and then I can give Johannes a go too. I think we need to, firstly, in academic environment, we need to work with agencies that enables us to commercialize these products. We're currently working with TIA, so the Technology Agency, Innovation Agency, and also Mechatronics, the automotive CETA of South Africa. And these are long-term projects. There's sort of 3 to 5 year projects where we take pieces of technology from the car and we commercialize these pieces of technology. And we have done so with a couple of pieces of them. No, it's not sold in the Nissan Leaf and the other production cars in South Africa yet, but we're getting there. I think we also, let Johannes answer on what we're planning for a 4-seater car at TUT.
Yeah, but I think it is quite important as well that some of the students that came from solar car teams, I think one student that did his master's degree with us, he moved now over to a company manufacturing electric vehicles. So you need to understand the fundamentals of, for example, battery management before you will be recruited by an international company where you need to design battery packs. Because if you don't understand these fundamentals, how can you do a proper design? So yes, definitely, whatever we implement here and the expertise we gain, is definitely being used in the automotive industry. And our plans is for the near future to build a cruiser solar car where we can actually have 2 or 3 participants or occupants in the vehicle. It is more like getting to the local public to understand and see, but it is actually viable to build not just a single seater, but also a multi-seater solar car. There's a lot of challenges. And if you want to build a single seater as well as a 4-seater, you need quite a big team. You need a big budget. You need lots of facilities. You need to streamline your processes very carefully. And I think COVID didn't really help in terms of adding a lot of workload to the lecturers who need to make everything online. So I think time was a bit of essence here, but I think that's definitely still in our radar that we do want to go that route and make it more like, listen here guys, this looks like a real car. And I think there, if you look at Lightyear 1, which is a commercial available solar car, you can buy it. It actually runs like a normal vehicle, and it does charge when standing in the sun.
Fantastic.
Wow.
That's quickly.
Divan?
I've got so many questions, but what's hit me this morning is the skills, the expertise, the brilliance that we have in this country, from the universities and outsiders. I've come from an OEM background where we build a car to a recipe, right? And it's designed in Germany or wherever else, and you get the recipe and you build the car accordingly. And what I've seen this morning is creative experts that now have the ability to build their own car, to design their own car on a budget. And if we have this kind of skills and expertise, what can we not do in the future? I mean, we can start building our own cars. I mean, the options are just endless. From aftermarket to sales to after sales to brilliant engineering, we could be designing stuff that the rest of the world will look back and say, wow, South Africa is the place to be. This is the incubator. Really. So well done. Again, and somehow, in my opinion, we need to link our universities, our skills, then into OEMs, into people and places where they can take full advantage of the skills that we have.
Yeah.
Well done, guys.
So I think for me, I think the big question is guys. Obviously, what we're talking about is adoption of EVs in South Africa. We live in a country that's wildly sunny. I think the stats that people talk about is we have 80% of our days are regarded as what they call sunny days, where we could charge, we can use solar technology. What is the big reason why we're not seeing more vehicles like a Lightyear 1? Where range anxiety is a real thing. I mean, we're preaching to converted. We all understand. Stop for coffee, charge, etc., etc. The person on the side of the road doesn't understand it. Now, if we could sell them a car that would have 450 Ks plus an extra 50 Ks to get them to their destination because of the sun, that to me seems like a real win. Mm-hmm. What are some of the reasons why we haven't seen this adopted by the other big manufacturers as technology that can be used as a viable thing in countries like South Africa, Australia, Chile, Brazil? Lots of countries around the world are very sunny.
Johannes, do you want to start off?
Yes, from what I understand is that I think it's first the perception of your general public. So listen here, what are the capabilities of an electric vehicle? And as I said in my introduction, people negotiate and say, but I can't drive to Cape Town with this thing. Why will I invest in it? But if you compare and see what is your average commute, someone working from home, dropping the kids off at school and back, you do maybe 30 kilometers max a day or 40 kilometers max a day. That's where you could definitely use an electric vehicle. So I think it's a matter of a mindset and say, listen, for 90% of the time, I will be able to use my EV. Maybe for the other 10%, I need to make another plan. But making that mind shift and say it is actually possible. I think that is the one thing. And the other thing is cost. They are very expensive compared to what you can buy if you buy an internal combustion engine. And I think if maybe rebates and subsidies will come into play, I think that will maybe tip the scale a bit in favor of EVs and say, listen, now it's worth investing in an EV in terms of the cost in the long run.
Yeah, I think if I can just quickly give my 2 cents on it.
Please.
I think we really need to get the government invested in this. Yes. And the government doesn't get on board if there are no policies governing these new areas, right? So we have been engaging with policymakers in the EV industry for a while now, but it's slow. The progress is slow. It's really slow. There's a lot of red tape to get through. So if you can get government on board by showing them and guiding them into the policies that are that aligns with the rest of the automotive and other industries, and you bring a business model to them, a viable model that they can implement, or you can assist them to implement in South Africa, then we can surely do it. But our government is not on board with this yet. And we can see it, for instance, with the extremely ridiculous import taxes on electric vehicles and electric vehicle components that we are currently seeing. It's because our government doesn't really understand what it's about, I think, and that's why the policy making is required, and why we need to get them on board. If we get the government on board, we can do this.
Fantastic.
Yeah, Tiaan, I agree completely. You know, and it's you know, we have the right bodies also to engage, and I think we need to engage faster and quicker. But there needs to be this mindset change. You know, we are the converted. We know that EV is the future. Now we just need to bring everybody else on board. But the level of skills and creativity that I see, I mean, we can have businesses, manufacturing facilities popping up, proudly South African for South Africa, for Africa.
Yeah. So Tiaan, you actually answered my question, which was going to be what was the one thing you would change to speed up the adoption of EVs in South Africa? And I think you've answered it very clearly, and it seems to be a resounding thing that's coming across: policy. And we need to engage with government. So it's been a pleasure, guys. I think you've shared with us a element of the E and the mobility matrix, which maybe a lot of people didn't think about, which is guys like you who are thinking the tip of the spear. You're working at composites, you're working on everything, and with those skills that Devon's been talking about, you guys are the guys at the coalface. You're developing those skills, so you're making sure that we have a sustainable economy in this thing, where we're bringing engineers out. So when we have companies like Mazibuko Motors launching, they will be looking for engineers, and those engineers could very well be coming from university teams such as yourselves. So guys, from us here in the studio, massive congrats. I don't think you guys get enough props for the work that you do, and the people and the skilled individuals that you send out there. So thank you very much for joining us, myself and Devon. Have a great Tuesday afternoon, guys.
Perfect. Thank you so much for having us. Privileged to be here.
Absolute pleasure, guys. Have a good day.
Thanks.
Thank you.
Bye-bye.
Cheers. So Devon, very interesting to see. I mean, we're looking at all the components now. We've got Mazibuko Motors coming out, launching, excitement, and then people say, what about the skills? How do companies
look at the skills? Look at our universities.
Where the skills are coming from. Guys like that, they're learning about all the different aspects. They're learning about battery management. They're learning about managing teams, production cycles, everything. This is how we make sure that our industry is sustainable. Because there's no point in us starting to manufacture cars if we don't have people who can do it.
And we have OEMs that may have to bring in an expat because we think they've got the skills. And their universities are better and their people are better. And from what I see today, wow.
Yeah, and I mean, I can tell you from personal experience, I know TUT is only one of a number of universities that have these kind of teams. This is not something that is unique. This is something that's out there, and the guys are doing it, and we are creating the future as we speak. Yeah. So talking of OEMs. Talking to an OEM that's very close to your heart, I know.
Absolutely.
We are very privileged to have in studio with us today Ms. Cleisha Johnson. She is the manager for electromobility and on-demand mobility solutions for BMW Group South Africa. So this is one of the brands that does currently right now have EVs in country. Obviously the Mini brand also falls underneath her. So they've got EVs in the country. Obviously everyone is talking about iX, iX3, all these, everything's, BMW is really pushing. And I think if you ask people in South Africa, which brand does electric vehicles, it would be, they're talking either BMW or Jaguar. That's what they're talking about. So we're really privileged to have her joining us, and I'm looking forward to hearing what she talks about as in the future is electric. And I think Cleisha is going to share some really insightful thoughts and some insights with us coming from someone from an OEM background, because we keep talking OEM. Now we have an OEM. So we're going to take a quick 2-minute break while we get Cleisha online, and then we'll be back with you, and we'll be talking to Ms. Cleisha Johnson from BMW Group South Africa.